Okay, let's talk about a different type of radical equation to solve. This is a little different from yesterday. Notice we got two radicals here. I don't have my little marker with me, so I'm going to have to use good old pointer. Based on these, they're all going to work the same way. We can't get radicals by, like, we have two radicals on one side, so we're just going to do this. We're just going to square both sides. Now we know this is just going to become x minus 9. The square root and the square are going to cancel each other out. But we need to deal with this. So let's go off to the side and work that out. And same as always, it's the square root of x minus 3 squared, so that becomes the square root of x minus 3 times the square root of x minus 3. So now we need to FOIL this together. So we do the square root of x times the square root of x is just going to be x. Then we've got the square root of x times negative 3, so it's going to be minus 3 square root of x minus 3 square root of x. And then minus 3 times minus 3 is positive 9. It follows the same pattern as before. We're just not used to this square root of x in the middle. So this in the middle is just going to become minus 6 square root of x. And so now we're just replacing the left side with all of this. Now I'm going to go ahead and subtract 9 from both sides, subtract this one over to here. So that's going to become minus x minus 18. Now the trick is if I subtract x from both sides, because I still kind of have, this square root of x to deal with, it's very weird. But if I subtract x from both sides, this is going to become 0. I'm going to lose my x altogether. And now I have this. I still want to get my radical by itself. So I'm going to divide both sides by negative 6. And so negative 18 divided by negative 6 is 3. And I get the square root of x equals 3. Now I square both sides and get that x is 9. Now we do have to double check. We have to plug 9 back in. The square root of 9 minus 3 is going to be 0. The square root of 9 minus 9 is also going to be 0. So that works. So x equals 9 is a valid solution. So there it is, our solution. Okay, you try this one, pause it here, work this one out, come back and check your answers. Okay, square both sides. We need to do the square root of x minus 1 squared. It follows the same pattern. You square this one, you multiply them together and double it, and then you square the last one. So we're going to get x minus 2 square root of x plus 1. Subtract 1 from both sides. So I pulled this one, subtracted 1 there, got minus 10. Now I'm going to subtract x, because those x's will just go away. Divide by negative 2. Square both sides. Get 25. Plug that into both sides, and you're going to find that 4 does in fact equal 4. So 25 is a valid answer. Okay, let's try this one. I think this one comes out just a little bit funkier. So we have to do this, square the first one, multiply them and double, and then square the last one. So that x plus 4 square root of x plus 4. Okay, I'm going to subtract 4. I'm going to subtract x. I'm going to divide by 4, and I believe Delta Math wants everything in this one in decimal form. I don't know why they won't accept the fraction form, 5 over 4. But now we just still square both sides. We get x is 1.5625. Plug those in, and you'll get 3.25 equals 3.25. So 1.5625 is a valid solution. This is one just to have you do it because don't be afraid of the decimals here. They're just numbers. Your calculator will handle them for you. Okay, so try this one. Pause it here, work this one out, and check your answers. Okay, so we need to do the square root of x minus 5 squared. So again, square the first one, x, multiply them and double it. So it's going to be minus 10 square root of x. And then square the last one, plus 25. So replace that over there. Now I'm going to subtract 25, subtract x, divide by negative 10, square that, and I get x is 3.61. So when I plug all that back in, I'm going to find negative 3.1 equals 3.1, which is not true. So 3.61 is not a valid answer. So we have no solution. Okay, there you go.